Hello everyone, this is Dr. N.Senthil Madasamy, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session.
In this session, topic to be covered is first part of cellular network. At the end of Unit 5, the students will be able to comprehend steps involved in investigating mobile forensics with case studies. At the end of this session, the students will be able to understand introduction about mobile forensics and base transceiver station, mobile station and cellular network. In this session, we will discuss the introduction about mobile forensics and base transceiver station, mobile station and the cellular networks. In next session, we will learn about cellular network types, SIM card forensics and type of evidence. Now we will discuss the introduction about mobile forensics. The field of mobile forensics has exploded in recent times. One of the most important areas of research for several reasons. First and foremost, the capabilities of cell phones have been greatly enhanced. These devices are arguably more important than desktop or laptops because they are generally always turned on and usually always mobile. Therefore, they continually record our movements and our activities and provide tremendous insight into our behavior. The communication on cell phone is very different compared to the traditional computer. Interestingly, criminals often say or text things on a cell phone that they would never do on traditional computer. Cell phone forensics has not always been taken seriously, even in 2008. If you had asking someone in law enforcement about investigating cell phones, you would have heard that nobody in the laboratory worked in cell phones, or that cell phones did not hold anything of a value. Some people might even have, and that only reason for cell phone forensic software was that some suspicious spouses bought the software to see if their partner was cheating. Hardware imaging devices not originally used for investigations. Cellular sold its hardware to cell phone retailers who needed a device to copy the contents of a customer cell phone and is SIM card to another cell phone. Usually, when the customer wanted to upgrade to a new phone. When law enforcement became involved in cell phone investigations, the celebrate made some minor modification and began selling many more devices. Cell phone forensics was always important, but not many people realized its importance. A cellular network is a group of cells. A cell refers to a geographic area within a cellular network. A cell site is a cell tower located in a cell. When you make a call with your cell phone, you connect. The communication is then transmitted to mobile switching center. The mobile switching center, MSC, is responsible for switching data packets from one network port to another on a cellular network. If the user is calling a user on a cellular network managed by another carrier, the call is routed from MSC to public switched telephone network. The public switched telephone network, PSTN, is an aggregate of all circuit switched telephone networks that connect all telephone networks worldwide. This is where the tolls for connecting calls across the different networks are calculated. The diagram that details the path of a cell phone call, that is the path from mobile station to PSTN through base station subsystem and network subsystem. Base transceiver station, a cell site also known as a cell tower, can be stand-alone tower or can be attached to a building or other structure with 3 panels on each side. Typically, each antenna has 3 sides. Usually, the middle panel is a transmitter and 2 outer panels are receivers. The cell tower is receivers. The cell tower is generally over 200 feet high, shown in the diagram. A tower can contain multiple antennas which are owned by different carriers. An antenna can be located on a cell tower or top of a building. Next, base station controller (PSC) manages the radio signals for base transceiver stations in terms of assigning frequencies and handoff between cell sites. When moving through an area, several base transceiver stations might handle your call. A handoff would occur from one PTS to another. There are 2 types of handoff. In a soft handoff, cellular communication is conditionally. The mobile equipment is simultaneously communicating with multiple base transceiver stations. The handoff is conditional because the signal strength on a new PTS are referred. In a hard handoff, the communication is handled by one base transceiver station at a time with no simultaneous communication. PTS evidence. From a computer forensics perspective, it is important to understand how the cellular network is structured so that the investigator can the type of evidence that can be retrieved from carrier network, even without access to suspect handset. Law enforcement can request the cell site records from a carrier for a particular cell phone user that indicate based on the data retrieved from the PTS. It is important for investigator to specify the desired format for the evidence. Getting the information in a spreadsheet is generally more helpful because the data can be easily stored and analyzed. The diagram shows sample data from a PTS. Next one is subscriber evidence. In addition to PTS evidence, law enforcement can obtain subscriber information, call detail records, and PUK codes. The subscriber records are personal details the carrier maintains about customers, include name, address, alternative phone numbers, social security number, and credit card information. The mobile station consists of mobile equipment, handset, and in the case of GSM network, a subscriber identity module, SIM. A international mobile equipment identity, IMEI, number uniquely identifies the mobile equipment or handset. The initial 6 or 8 digits of the IMEI type allocation code tag identifies the type of wireless device. The website www.nobi.com/tagquery.php allows an investigator to enter a tag or IMEI to discover details about a specific device. The IMEI is generally found by removing the back of a cell phone and then looking under the battery as shown in the diagram. A Universal Integrated Circuit Card UICC used to uniquely identify a subscriber on GSM or UMTS network. With a GSM network, a smart card is SIM. With a UMTS network, the smart card is a Universal Subscriber Identity Module, USIM. Identifier, MEID, is an internationally unique number that identifies a CDMA handset mobile equipment. The MEID was previously referred to as Electronic Serial Number (ESN) before it was replaced by Global MEID standard around 2005. An electronic serial number (ESN) is an 11-digit number used to identify a subscriber on a CDMA cellular network. The ESN contains a manufacturer code and a serial number that identifies a specific handset. Both ESN and MEID are noted on handset in both decimal format and hex format. The website www.meidconverter.com allows the users to convert between ESN and MEID. So view both decimal and hex values of an ESN or MEID. Some providers like Virgin Mobile USA provide a lookup features for subscriber details using the MEID. Many CDMA cell phones have a subsidy lock subscriber to a certain cellular network so that a cell phone can be sold for free or at a subsidized price. From a forensics perspective, this means that the phone's file system might not be able to be recorded with an active service programming code (SPC). All cell phones sold in the United States have an FCC ID. An FCC ID is a number issued by the Federal Communication Commission (FCC), indicating that the handset is authorized to operate on radio frequencies within FCC control. The diagram shows a sample FCC ID on a handset. The FCC ID can be viewed by removing the back of the cell phone and taking out the battery. Investigators can enter the FCC ID on the FCC website http://transition.fcc.gov/oet/ea/fcc-id. Now, after you enter the FCC ID, you can download a manual for cell phone. This is important for an investigator who networks for proper containment. Additional information about cell phones and cell phone carrier can be obtained from the websites www.phonescoop.com, pdatp.net, and www.gsmarena.com. SIM card might need to know about the features of a SIM card identifies a user on a cell phone, and more importantly wants to know how to remove the cell phone from the IMSI. The SIM cards are found in cell phones that operate on GSM cellular network and usually IDN network cell phones. A user can simply add a SIM card to an unblocked cell phone. Not all US cell phone carriers allow a user to purchase a SIM card and use the handset on another network. In the European Union, generally all GSM compatible cell phones can be unlocked. In fact, in some European Union countries, it is illegal for cell phones to be locked. International Subscriber Identity Mobile (IMSI) is an internationally unique number on the SIM card that identifies a user on a network. The mobile country code (MCC) is the first 3 digits of the IMSI. The preceding 2 digits are the mobile network code (MNC). For example, MNC 026 for MCC 310 represent the carrier T-Mobile MSA. The final part of the IMSI is the MSSIN, which consists of up to 10 digits. A mobile subscriber identity number MSIN is created by a cellular telephone carrier and identifies the subscriber on the network. The mobile subscriber ISDN MSISDN is the phone number for the subscriber. The MSISDN is a maximum of 15 digits and is comprised of the country code CC, the numbering plan area NPA, and subscriber number SN. The country codes are relatively easy to find. For example, in the America, the CC is 1 because it is in zone 1. For Trinidad and Tobago, it is 1-868. European countries are in zone 3 and zone 4. For example, Ireland in zone 3 is 35-3 and the United Kingdom in zone 4 is 44. The numbering plan area for the Nassau country, New York, is 516 and is also referred to as an area code. The SIM card also includes an ICC ID, the Integrated Circuit Card ID. Can be a 19-digit number physically located on the SIM card, or it can contain fewer numbers seen in the diagram. First 2 digits of the IC ID are referred to as Major Industry Identifier MII. The ICC ID can be accessed via SIM card in the EF ICC ID file. International numbering plans. The website www.numberingplans.com is a tremendous resource for mobile forensics examiners working with the GSM cell phones. The website's number analysis tools, which allow the user to conduct an analysis of the following: phone number, IMSI number, IMEI number, SIM number, ISPC number. An International Signaling Point Code (ISPC) is a standardized numbering system used to identify a node on international telecommunication network. Next, authenticating a subscriber on a network. The mobile switching center is where the user information passes to the home locator register. Center. The home locator register is a database of a carrier's subscriber and includes those users' home addresses, IMSI, telephone numbers, SIM, and ICC ID, and services used. The visitor locator register is a database of information about roaming subscriber. A subscriber can be found on only the HLR but can exist in multiple VLR. The current location of a mobile station handset can be found on VLR station. Handset can be found on VLR as well. The VLR also contains the temporary mobile subscriber identity. The temporary mobile subscriber identity TMSI is a randomly generated number that is assigned to the mobile station. The VLR when the handset is switched on and is based on the geographic location. The equipment identity register EIR is used to track the IMEI numbers and decide whether an IMEI is valid, suspect, or perhaps stolen. The authentication center issues the subscriber an encryption key that encrypts wireless communication between mobile equipment and network. In this summary, we learned about introduction about mobile forensics mobile station under cellular network. I mentioned the references here.
I hope you found this video is clear about the topic I lecture. Thank you and have a pleasant day.